All right, so what I'm going to do is just kind of walk through an overview here. Please jump in with any questions. We're going to talk a little bit today about kind of a mindset that I think has helped us. And we're going to talk a little bit about Scala and the option type. And we're going to talk a little bit at the end about a new feature that's coming in Scala 3 where nulls really shouldn't be a thing anymore. Okay, so I think one of the things that helps us a lot is to view the things that come from the outside world through sort of a common abstraction. So we view our program as a set of functions, and typically in Scala, we might write a function or talk about a function as being a function from A to B. Maybe it takes a string and returns an int. Obviously, they can take more than one argument, but we tend to use that language. And inside of our program, all of the functions call each other, and they're all under the type system, and it's all nice and neat, which is the same way for most languages. But when we get something like an HTTP request or an SQS message or a cron event, we view those kind of the same way. It's the outside world that's trying to call one of the functions in our program, but they can't do it because they're not in Scala. So they have to do something a little different. They can't send Scala values, so they have to send us bytes. So I apologize. Some of this is kind of painfully obvious, but I think what we do a little bit differently is some of the emphasis we put on certain things. So when we look at all these things in the same way, we see them as all having one common problem, whereas they're a source of complexity. If you deal with data from the outside world, some values might be missing, some values might not be well typed, some values might have names that don't make a lot of sense to us, or they might be have the same value in multiple places and it's redundant. At Deer, we deal with this a lot because on my team, a lot of our interactions are with the Gen 4 display, and data architecture designs the protobuf messages that we talk to the display through. And these tend to have loads of values that are not required, even though they really are required. And our program should fail if they're not there. They tend to have loads of values that are just loosely typed as strings, even though we know they have to be UUIDs or they have to be URLs or some other type. They tend to have loads of data we don't care about and loads of data that may be the same values in multiple places, may be deeply nested. And there often arises questions about where do we get it from? Where does the display put this date value? Because there's 6 places in the proto that it could be. So what we've done in some cases to try and help with that is to emphasize contracts. And even for async messaging, we tend to use contracts. We haven't completely got the Gen 4 on board data architecture, but some of the teams we message with, we do. And I think in an ideal world, we would be using something like async API. I'm not sure how many of us are using this, but this is kind of like Swagger for your contract, for your async messages. We didn't know about this when we started this effort, and so we actually did just use Swagger. And here's an example of our contracts. And I should have mentioned that what you're going to see today is really a number of ideas that are pretty small, that when they all are put together, have helped us deal with null values and other kinds of complexity that come from the outside world. And I'll talk in a minute what I mean by complexity there. But here's an example of one of our contracts, our messaging contracts. And since Swagger is sort of HTTP oriented, totally HTTP oriented, we just use the models in the Swagger. And then some of these are the top level models that are the messages, and we indicate that at the top in the comments, which is kind of hacky, but it's better than using the no contract like we had before. I think async API would be a lot nicer for this. We might talk a little bit more about contracts in a minute, but another thing that we do is we recognize that all of these things that come from the outside world is really the outside world trying to invoke some specific function. Maybe they want to look up a customer, and maybe they're sending me a customer ID and or a customer name or something like that, and they want to invoke a function that's going to return a customer. Well, the first thing that we do is we pipe all of these guys through a decoding function. I think you all probably do something similar. The only thing that we do a little differently is we just kind of give a name to this, and maybe some of you do too, where we elevate to the level of, we call this our decoding layer. I think in domain-driven design, they call it the anti-corruption layer. And we kind of treat this layer like it's holy. This is where we squash out a lot of complexity. And what I mean by complexity here is, like if you think about missing values, null values, values that are nullable. If I had, let me get over to a code editor here. So if I have some class, maybe in Scala, it would look like this. And it had 3 fields. And let's pretend these were all null fields. It could be null, right? So if I'm just looking at that class, the way I think about this today, which is different than how I used to think about that, think about it, is I immediately look at this and I think, okay, you know, there's the case where those fields, none of them are populated. There's the case where just is populated. Now, probably some of these are kind of silly edge cases, right? Probably I know that some of these shouldn't happen. They don't make sense. The fact is that if in my contract or in my data types, I model these as possible, then I kind of have to think about them. Now there's 4 more cases, and I'm not going to go through and copy them all. Well, maybe I can here. Yeah, I probably can. Let's see, have I done something wrong there? Feels like I missed something. Yeah. I did. I missed one. Okay. So you can see what happened there is if I have 3 fields and they're all optional, if we just think about absence or presence, we've got 2 to the n cases. And so, you know, we had protobufs that came from the Gen 4 display. They had dozens of optional fields. And in some cases, maybe you should know that they're not going to happen. But in a lot of cases, we really didn't. And we had people that would just trip over that all the time. So this is one thing that has helped us. We've tried to encourage people to view optional values as a source of complexity and to think about it numerically this way. So the way that we would typically model something like this, now that we've talked a little bit about these decoding functions, they go from the untyped junk in the outside world to something that's well typed on our side. Let's say it was a customer request. So we might have a customer request. I would probably in my contract say that this can, you know, take a UUID, and maybe that's all that I have. And so in my decoding function and in my contract, I would indicate that this is required. I would take that in, and I would fail in all of these decoding functions. I have this try here. If you're in a language that doesn't have try, you might use something else. We might actually use a little different class, but I thought try was just easy to understand. But the common abstraction is that we know that any of those decoding functions could change, and that decoding function is where we trust that we're going to take any values that are supposed to be required, and we're going to fail and reject the message if the required values aren't there. And then if there's a value for something like a UID or URL, we're going to fail if it's not the right type. So once you get past the decoding, you'll have and it succeeds, you'll have a well-typed model, which then ends up eliminating a bunch of branches in the code downstream. We just went through some refactorings to clean up some cases like this. And I don't have data, but I can tell you that we saw a lot of edge cases and unnecessary tests and confusing bits of the code went away. We had a case, we haven't talked about option yet, so maybe I should back up one little step here. But in Scala, if some of these fields were optional, we would represent them this way. So in my code today, once I get through the decoding layer, if I see this class, I know bar is going to be there. I just assume it. And it's very rare that I deal with a null value once I get past the decoding layer. And if I do, it's almost invariably a bug in the decoding layer. So once I get past the decoding layer, now I have this, and I know I have a bar. I know I have a Baz. I know I might not have a Biz. So I know I've got two cases there that I might have to deal with. And so the real world situation that we were in recently was where we had an important class that looked more or less like this. And we had an ID, and a session could be teamed. And if a session was teamed, it essentially had a team ID. It had a team name. Let's go back this way. And a timestamp. And these were optionals. So these were originally modeled as optional. And so looking at that, I can see that there's 8 cases to consider there, right? What if I have none of those? What if I have the team ID, but not the team name? What if I have the team name, but not the team ID, and so forth? Really, in reality, they need to either be all present or all absent. And so we made a small refactoring. Sorry, I didn't throw anybody there, but I wrote the case, but case class in Scala, it's just an immutable structure. So we basically did something like this, where we created something with a team. Which has all 3 values. And then we change this guy to be this. So hopefully you can see that this goes from a situation where, there's at least 2 to the 8th edge cases, 2 to the 3rd, excuse me. So 2 to the 3rd, because there's 3 options. So that's 8. 8 different edge cases to consider there. We brought it down to 2. And so what was the practical effect of this? The practical effect of this is that we discovered that a boatload of our tests were cracked. Because a boatload of our tests that had been written, probably not when the original app was written. That was probably written by people who knew the domain well. But probably later on, we had tests that people didn't understand the domain real well, and they wrote tests that generate test data. And if you write, the tests to generate the test data, and you have to know anytime you create a team session, you have a team ID, you have a team name, you have a team timestamp. That was not happening. And so we had boatloads of tests that were creating data with like a team name, but not a team ID, or I think it was like a team timestamp, but not a team ID and not a team name. And that's not something that can really happen. we found some code in the production code, one edge case that was making a mistake and not setting the timestamp, let's say the other two values. So by changing it this way, now some of those mistakes are just not possible because we've reduced the number of edge cases we can consider. Yeah, I think I said we try to type our contracts as tightly as we can. So we'll have, here where we've got a trace squid that goes through, we've indicated it's a UUID, and that will actually get generated to be a UUID field in a class. We tend to look at optional values very skeptically. We know that some data is truly optional, and that's important. But oftentimes, fields get marked as optional because we're just not sure if we might need them. We tend to lean on fields are required by default. If something is optional, we just kind of want to understand why. We try to minimize the surface area of the contract and not accept if somebody outside says, oh, well, the message you're going to receive has these things in it. Maybe we don't care about 2 or 3 of those things, and either they're not in the contract or they're not in the class that we decode to. Yeah, I was going to say we treat that decoding layer, we treat that as pretty much a holy artifact. It's our first line of defense against a lot of edge cases. And one thing that's really, I think, crystallized in my mind is if you've ever seen cyclomatic complexity, this is a diagram here of some code on the left. And the code on the left has a while loop and an if statement, and then the switch statement. I don't know what language this is, probably C. And there's a way of looking at this through this diagram on the right, where if you took the arrows away, you could view this as a circle or a cycle. You could view this as the cycle on the right-hand side here. This is a cycle on the left-hand side. You could view this as a cycle, and that gets you to 4, and then you always add 1 just for the default case. And so this gets a complexity score of 5. If you think about your whole program, if you sort of inlined all the functions and it was one giant method, which would be horrible, but you could imagine like totaling up the complexity. When we allow stuff into the program where there's unnecessary edge cases to think about, in my view, it tends to have a multiplicative effect. I had a really good animation here. I probably won't be able to find this now, but yeah, I won't be able to find it. But I think about it kind of like a crystal or a tree, whereas like if I put the seed in that is really small, I'll have smaller things that, down the line. So I'm pretty aggressive about leaning on this layer to minimize complexity down the line. And I think the last thing I wanted to show today is Scala 3's support for a feature called explicit nulls. I think I have some code for this here. Yeah, we can just focus on this bottom part here. So in Scala 3, there's going to be a feature where you can enable compiler flags called explicit nulls. And there's another one called safe init that just covers an edge case. But when this feature is enabled, null is no longer a value that can be assigned to another type like string. So this would not compile if you have this feature enabled in Scala 3. It'd say it found a null but required a string. And instead, you'd have to explicitly say that this type is string or null. And that might be something that's a little bit unfamiliar, putting types together with or, but that's kind of an underlying feature of type theory, and it's starting to creep into some languages now. We kind of have done it in the past a little bit with things like enums, but this allows you to do it with types maybe that you don't own. You don't have to do it through inheritance. So that's what you're seeing here is this is a string or it's a null. And this would compile because I've said that x2 is either a string or a null. And if I wrote a function to handle a value of that type, the compiler is going to make me handle it. Oh, my syntax is a little bit bad here. That closing brace shouldn't be there. And if I tried to write this assertion in a test, this wouldn't compile either because you can't compare a string to null. And when you call a Java API with this feature enabled, this won't compile either because Scala will know that the compiler will know that you're calling a Java API, and it will patch those methods return types to be string or null. Now, I have not used this feature yet. I just kind of wanted to show it to you as a preview. And I think I might have glossed over option. I know it's a thing in Java and it's a thing in other languages now. But if I went too fast over that, I can go over it a little bit more. I think that's all that I had. Were there any questions?
Cool.
I'll see you later.
See ya.